All right, now that we have talked about how to describe sampling distributions for difference of means and what the conditions are for performing inferences, let's go ahead and actually do some inference here. On this example here, we're going to construct a confidence interval. So let's read through it here. It says the Wade Tract Preserve in Georgia is an old-growth forest of longleaf pines that has survived in a relatively undisturbed state for hundreds of years. One question of interest to foresters who study the area is how do sizes of longleaf pine trees in the northern and southern halves of the forest compare? To find out, researchers took random samples of 30 trees from each half and measured the diameter at breast height, dBH, that'll be our size metric, in centimeters. Here are comparative box plots and data of the data and summary statistics from Minitab. Here is our summary statistics. Construct and interpret a 90% confidence interval for the difference in the mean dBH of longleaf pines in the northern and southern halves of the Wade Tract Preserve. So our goal is to estimate what is the difference in size between trees from the northern half to trees from the southern half in this tract preserve. As we look at it, it appears that the southern trees are larger than the northern trees. So we're gonna, in order to keep our numbers positive, we'll go ahead and do, we'll subtract southern trees minus the northern trees. We'll see what I mean here in a minute. So we want to start by indicating our plan state, do our state plan do conclude process. So we'll do our state step first. What we're trying to do, we want to estimate, what we're trying to estimate is the difference between the size of the northern trees and the southern trees. So we want to estimate, I'm going to just call them mu1 and mu2. So I'll call mu1, we'll say is the northern trees. I'm going to be lazy and just write u1 minus u2. All right, and I might have just said u1 is northern trees, but we're going to actually do u1 as the southern trees. Since they're larger, we'll put the southern trees up front. And we want to estimate that with 95% confidence, 90% confidence. And we can go ahead and define our variables here where mu1 is the true mean dBH for trees in the southern half of the tract of the preserve. Okay, and mu2 is the true mean dBH for trees in the northern half. Okay, so state is what we're trying to estimate, defining parameters, relevant parameters, and indicating confidence level. And then we can move on to the plan step. How will we estimate that? Well, we're going to construct a confidence interval. So we will construct a 90, well, we already indicated the confidence level. So what is the type of interval we're going to construct? Well, so now we have two samples, and we talked about in the previous videos that to run inference for means, we need to use t as our test statistic. So we will construct a two sample t interval for the difference of these two means. Okay, we want to be really specific when we name the procedures that we're going to use. So we're using a two sample t-test for the difference of two means. Okay, of course, we're only going to do this if conditions are met. All right, so then what are the conditions that we need to meet? It's the same three we've been doing for means the whole time. So we'll check our random condition. The random condition needs to be met for both populations. It says to find out, researchers took random samples of 30 trees from each half. So random samples of 30 trees from each half, right? And that satisfies the random condition for both populations, both groups. We then need to check the 10% condition, right? So there's 30 trees in the north sample, 30 in the south sample. If this is it says a Wade Tract Preserve in Georgia, old growth forest, I think it's safe to assume that a forest has 300 trees in the northern and southern half each. So we can just say it seems reasonable to assume there are more than 300. 300 equals 10 times 30, our sample size. More than 300 trees in each half of the forest. And the 10% condition is met. Last is the normal condition. The normal condition is satisfied either by normal populations, which we aren't told, or the large sample condition. In this case, large sample condition is met. So in the south, 30 is n equals 30, I should say. N equals 30. So that meets the condition. And in the north, n equals 30. So in both samples, the sample is large enough to satisfy the large sample condition. Therefore, it is safe to use normal computations. Okay, so we've checked our conditions. Now we're ready to actually do the process here, constructing the confidence interval. You can, if you're feeling ambitious, go ahead and compute it all very carefully using the formula that was given above. The t-value is found using the 90% confidence level in the t-table that we saw in our reference sheet back in chapter 8. And you can just plug in everything here. But you'll notice that that gives us a lot of different computations to do, and it gives us a lot of different substitutions and a lot of different opportunities for error. So I and the textbook both suggest just using the calculator to spare you from that level of risk, but you're welcome to use the formula if you want. Either way, in the do step, you need to identify the test or interval that you're doing. So you have to identify it by name or by formula in the do step. So we're going to do the 2 sample t interval, and we're going to go find that in our calculator. Let me see, just one sec. Yeah, all right, so we're going to go find that in our calculator. And let's just clear this old stuff out here. So it's going to be under the menu, of course, statistics. So now that we've done our confidence interval chapter and our significance test chapter, it can start to get a little confusing figuring out where we're going in our calculator. So pay close attention to what we're doing. We're trying to estimate the difference in means using a confidence interval. So we want to go stats, confidence interval, 2 sample t interval, right? Since we're doing a difference of means. And we were not given data, we were given the stats. So it's going to ask us for a few different stats here, kind of a bunch of things to put in here. It asks us for, and I'll go ahead and label these here. It asks us for the sample mean from the south, so x bar 1, which is 34.53. It asks us for the standard deviation from the south, which is 17.5, and it asks us for a sample size, which was 30. Then it asks us for x bar from the north, which was 23.7, standard deviation from the north, which was, okay, I got my stats a little crossed up here. The standard deviation from the north is 17.5. I messed up this one back here. The standard deviation from the south is 14.26. So again, be really careful, pay close attention to detail. And the sample size from the north is 30, and it didn't show right when we were looking at it a minute ago, but also we need to make sure we indicate the confidence level. Okay, so we'll just say that here as well. C level equals 0.9 is what was given. Okay. So let's go ahead and enter that all into the calculator. again, we made north the first population since it has the larger average. Excuse me, we made south the first population, so the south has a sample average of 34.53. It has a standard deviation of 14.26, sample size of 30. The north has a sample average of 23.7 with a standard deviation of 17.5 and a sample size of 30. And don't forget to change the confidence level. We're doing this at the 90% confidence level. Once we have everything entered in carefully, we're not going to pull the data here. Don't worry about that. You're never going to need to change that. We can go ahead and execute the test and find our confidence interval. Okay, there's a lot of information here, but all we really care about for reporting purposes are the degrees of freedom and the interval itself. Okay, so we saw, this is a little bit strange here, the degrees of freedom was 55.73. So there's a much more complicated formula for figuring out the degrees of freedom that we're not going to go into at all. If we were doing it by hand, you would need to use, again, the one less than the smaller sample size. So these are the same sample size. So we would, if we're doing it by hand using the chart, we would use degrees of freedom 30. Okay, or excuse me, 29, one less than the sample size. I'll probably post another video where I work through just the do step by hand, so you can see what it would look like by hand. But again, I would strongly encourage you just use the calculator. And then the interval itself is given. The lower bound is 3.94, and the upper bound is 17.73. So 3.94 to 17.93 is our confidence interval. That finishes our do step. Now we're ready to actually go ahead and conclude, which is our interpret. The question asks us to construct the interval and interpret. So remember, 90% confidence means we are 90% confident that the interval from 3.94 to 17.93 captures the difference. Remember, we're trying to estimate the difference between the true mean from the south and the true mean from the north. So we think that that interval captures the difference between the true mean dBH of southern trees and the true mean dBH of northern trees. Right? Make sure you give clear context and clearly describe the difference that you're estimating here using the confidence interval. So this gives us pretty strong evidence that the southern trees are in fact larger, since 0 is not one of the plausible intervals and all the plausible values are positive. We have a high level of confidence that the southern trees are larger, and we would estimate that the actual difference is somewhere between 3.94 and 17.93. Our specific point estimate would be the midpoint of that, which we could glean off our calculator, was 10.83. Okay, so that is constructing a confidence interval using, or for the difference of two means. The next page in our notes is just walking through the calculator, how to do that in the calculator. So we already just walked through that. Making sure that when we use the calculator, we identify the procedure by name. We specifically give the interval, and we indicate the degrees of freedom. Those are our key things that we need to make sure we indicate. So that's kind of wrapping up our first half of this section. So for practice exercises, I think I split that up differently and assigned these already in your previous section in teams. Either way, you have to do all the problems at some point, but here are the exercises for this first half of this section on constructing confidence intervals for the difference of means.